In example number 14, we have a bucket that weighs 4 pounds and a rope of negligible weight are used to draw water from a well that is 80 feet deep. The bucket is filled with 40 pounds of water and is pulled up at a rate of 2 feet per second. But water leaks out of a hole in the bucket at a rate of 0.2 pounds per second. Find the work done in pulling the bucket to the top of the well. Now the work that's needed to lift the bucket is going to be 4 pounds times 80 feet to get 320 foot-pounds. Now at time t seconds, the bucket is x, which is equal to 2t feet above the original depth of 80 feet. But now it holds 40 minus 0.2t pounds of water because you have 40 pounds of water in the bucket and there's water that's leaking out of the bucket at 0.2t. Now here where we have x, which is equal to 2 feet per second, we need to be able to solve for t. So t is going to equal 1 over 2 x subscript I. So in terms of distance, the bucket is going to hold the following. It's going to be 40 minus 0.2 times 1/2 x subscript I pounds of water when it is x subscript I feet above its original depth of 80 feet. Now moving this amount of water is a distance delta x that requires 40 minus 1 over 10 x subscript I, because 0.2 is 2 over 10. Multiply those fractions to get 1 over 10. Delta x foot-pounds. So now the work is going to equal the Riemann sum, which is the limit as n approaches infinity of I is equal to 1 to n of the function 40 minus 1 over 10 x subscript I delta x. So now here is our function. It's going to go from 0 to 80. The function is 40 minus 1/10 x dx. Taking the antiderivative, we get 40x minus 1 over 20x squared. Substituting in the value of 80, plugging in 0 is going to give you 0. So we have 4 times 80 minus 1 over 20 times 80 squared, which is 3200 minus 320, which gives us an answer of 2,880 foot-pounds. And so adding the work of lifting the bucket gives a total of 3,200 foot-pounds of work.